All right, let's talk about something that I know can feel like a huge wall in algebra, logarithmic equations. But here's the thing. What if I told you they're way simpler than they look? We're going to break it all down and make it totally clear. Let's get into it.
So, be honest. You see log in an equation and your brain just kind of freezes up, right? Yeah, you are definitely not alone there. But listen, it's not some kind of secret code. Think of it more like a puzzle. And I promise, by the time we're done here, you're going to have every single piece you need to solve it. No problem. You see, the real secret to cracking these log equations isn't about learning some brand new complicated math. Nope. It's all about transforming the problem. The whole goal is to change it into a format you already recognize, like a simple linear or quadratic equation that you're already a pro at solving.
And really, this is the entire game plan right here. It's basically a two-step dance. If you've got more than one log, your first move is to condense them all down into one single log. Once you've done that, you take that single log and you flip it into its exponential form. That's it. Seriously, that core strategy unlocks pretty much everything else we're going to do. Now, to pull off that two-step strategy, you only need what I like to call your two master keys. These are really the only two main tools you need in your toolbox. Just about every log equation you'll ever run into can be unlocked by one of these two keys.
And here they are, the two main situations you'll face. Over on the left, we've got type 1, a single log on one side that equals just a regular number. And on the right, you've got type 2, a log on one side equals another log on the other side. And the really important part here is that they have to share the same base. So let's look at the key for each one. For a type 1 problem, this conversion formula is your key. The expression log base b of x equals c transforms into x equals b to the power of c. Just look at that. The log completely vanishes. This is exactly how you turn a scary-looking log problem into something way, way friendlier.
Now for type 2, the key is even easier. It's called the property of equality, and it's super intuitive. If you've got two logs, and they have the same base, and they're equal to each other, well, it just makes sense that the stuff inside the parentheses has to be equal too. So you can literally just drop the logs and set m equal to n. So simple.
Okay, before we dive in and solve anything, we have to talk about the single most important part of this whole process. This isn't a friendly suggestion, okay? This is the one golden rule that you absolutely positively can never, ever skip.
And here it is, the big one. The argument of a logarithm, the expression inside the parentheses, can never, and I mean never, be 0 or a negative number. That's just a fundamental rule of math. So what does that mean for you? It means, after you solve for x, you're not done. You have one more mandatory step. You have to plug your answer back into the original equation, just to make sure every single argument is still a positive number. And if you find a solution that makes any of those arguments 0 or negative, it's a fake answer. The fancy math term for it is an extraneous solution. And even if you did all your algebra perfectly to get there, that answer is invalid. You have to reject it. Just throw it out.
Okay, enough with the theory, right? Let's put our new keys to work and actually see this stuff in action. We'll start with a nice, straightforward example, and then we'll slowly crank up the difficulty.
All right, here's problem number 1. We've got a single log that equals a number. So what type is that? Yep, it's clearly a type 1. We know exactly which master key we're going to use for this. Let's walk through it. First step, we convert. We use our first key. The base, 2, swings over and becomes the base of the exponent. So we rewrite this as x minus 3 equals 2 to the power of 5. Easy. Step 2, we solve. Well, 2 to the 5th is 32. Add 3 to both sides and we get x equals 35. But wait, we're not done. Step 3 is the most important. Check it. We apply our golden rule. Plug 35 back in. The argument becomes 35 minus 3, which is 32. Is that positive? Yes, it is. So our solution, x equals 35, is valid. Okay, time to level up a little bit. Now we have an equation with two separate logs. So what was our core strategy? Before we can even think about converting, we first have to condense these two down into one single logarithm. Step 1 is to condense. Since these two logs are being added, we use the product property, which means we combine their arguments by multiplying them. That gives us log of x times the quantity x minus 3. Now for step 2, convert. This is a type 1 problem now. The base isn't written, so we know it's base 10. This becomes x times x minus 3 equals 10 to the first power.
For steps 3 and 4, we just solve. We distribute the x, which gives us a quadratic equation. We get everything on one side to equal 0, we factor it, and bam, we get two potential solutions, two candidates, x equals 5 and x equals -2. And this is where that golden rule saves the day. It is so important. We've got to check both of these potential answers. Let's start with x equals 5. Plug it in. Log of 5? Yep, that's fine. And log of 5 minus 3? Well, that's log of 2. Also fine. So x equals 5 is a real, valid solution. Awesome! Now, what about x equals -2? The very first thing we'd write is log of -2. And stop. We can stop right there. You can't do that. That's not possible in the world of logs. This, my friends, is a classic extraneous solution. We throw it out, and that leaves us with just one answer, 5. Okay, for our last example, we have a classic type 2 problem. We've got a log equal to another log. In this case, they're both natural logs, which just means they have the same base, e. Now, this might look a little advanced, but it's actually the most straightforward type to solve. So for this one, we grab our second master key. Step 1. Since the logs have the same base, we can just drop them. We set the arguments equal to each other. 2x plus 1 equals x plus 4. Look at that. Step 2. We solve what's left. It's just a simple linear equation. We solve for x and we get 3. And of course, step 3, our final crucial check. Plugging 3 into the first argument gives us 7. Plugging it into the second argument also gives us 7. Are they both positive? Yes, they are. Our solution is good to go. So there you have it. We've seen the methods, we've seen the golden rule in action. So let's just do a quick recap of the biggest traps that students fall into, just so you can make sure you avoid them. Pitfall number 1, and it is the biggest one by far, is skipping the check. I really can't say this enough times. Just assume every single problem has the potential for a fake answer, and then prove yourself wrong. Always check. The second big mistake is trying to condense logs when they're on opposite sides of the equal sign. You got to get all your log terms grouped together on one side of the equation first, and then you can condense them. So we've spent all this time mastering the how, but it's totally fair to ask why. I mean, why do we even need to solve these things? Where do they actually pop up in the real world? Well, logarithms are absolutely essential for measuring things that exist on a massive scale. Think about it. Chemists use them all the time for pH levels to measure acidity. Seismologists use them to calculate the magnitude of earthquakes. That's the Richter scale. And audio engineers use them to measure sound intensity in decibels. The skills you just practiced are literally used every single day in major fields to help us make sense of our world. You know, you might have started this feeling a little nervous when you saw a log, but look at you now. You have this strategy, you have the 2 master keys, and you have the 1 golden rule. You have all the tools you need to decode these problems. So the only question left is, what are you going to use them to solve next?